27 to the 2/3. What is the cube root of both numbers first? That's what raising something to the 2/3 is. Taking the cube root of both numbers. Once I do that, on that 2/3, and that's raised to the numerator, which is 2. 2 squared is 4, 3 squared is 9. Number 2, we're going to evaluate negative 64 to the 2/3. You can take the cube root of a negative. You're not going to be able to take the cube root of a positive. You can take the cube root of a negative. The cube root of 64 is negative 4. And then we apply the exponent. Negative 4 squared is 16. So negative 64 to the 2/3 is going to be a positive 16. Negative 4 squared becomes positive. Number 3, we're going to write this as an exponent. This entire thing, this 8 to the x fourths, is in a radical. And this entire thing is really this, raised to the first power. The entire thing is in the radical. And now when I change it to exponential form, it's parentheses x to the 4th. It's an exponent over an index over 1/5. For number 4, same deal. Cube root of 4x squared, I want to take the cube root, and it's 4x squared is raised to the first power. Okay? To get a index that's different than 2, we're going to get 4x squared to the 1/3. And that's our answer for number 4. All right, so for number 5, they want this put in radical form. Okay? We've got to recognize that exponent only goes to what? The exponent only goes to what? It only goes to y. It doesn't apply to 7 because there aren't parentheses there. From there, it's simply this. The 11 is the index, and the 5 is the exponent. Number 6, same deal. 4y to the 3/5. That 3/5 only applies to the y. Y, 5th root of y cubed. The denominator becomes your index. The numerator becomes your exponent. When we evaluate radicals, negative 27, a to the 8th, b to the 12th. The cube root of negative 27, negative 3. We take each exponent and we divide by the index. The quotient is our exponent on the outside. The remainder is our exponent on the inside. 8 divided by 3 is 2. Remainder 2. So an a squared on the outside, an a squared on the inside. 12 divided by 3 is just 4 with no remainder. If there's no remainder, that variable doesn't go back in the radical. We can take it completely out. b to the 12th, the cube root of it is just b to the 4th. And this is my answer. For 8, we should know at this point that if you have a square root symbol and you don't have an index assumed to be 2, the square root of 144 is 12. 3 divided by 2 is 1. We don't need to write that exponent. Remainder 1. 5 divided by 2 is 2, so b squared, remainder 1. And there's our answer. For number 9, the cube root of negative 4ab to the 4th times the cube root of 2ab squared, or I'm sorry, 2a squared b to the 4th. You can't multiply unless you have the same index. Here we clearly have the same index, so we can multiply. Negative 4 times 2 is negative 8. A times a squared is a cubed. B to the 4th times b to the 4th is b to the 8th. The cube root of negative 8 is negative 2. 3 divided by 3 is 1, so a to the 1st power. 8 divided by 3 is b squared. Radical b squared. Same process. Fourth root. 4a squared b to the 7th times the 4th root of 64a squared b to the 4th. This is number 10. Same index, so we can multiply. 4th root 256, a to the 4th, b to the 11th. Same basis, you're adding exponents. The 4th root of 256 is simply 4. 4 divided by 4 is 1. 11 divided by 4 is 2, remainder 3. So it's b squared, 4th root of b cubed. And there's our answer. Guys, before I go back, I'm going to go back to before I move on, I'm going to go back to number 9. A mistake was pointed out, rightfully so. Move this over a little bit if I can, I guess I can't. This should be a cube root right there. I missed not putting the sign there. So someone mentioned that. They're 100% right. See how we have cube roots at the radicals? There should have been a cube root there as well. So it's there now. So thank you to that student who wishes to remain in. All right, simplify. 5 root 12 plus 2 root 27. Remember, to kind of simplify these, you need the same number under the radical. So let's look for it. We're going to break the 12 down. It's 2, 6, 2, 3. So 12 can be written as 5 times 2 root 3 plus 27 is 3, 9, 3, 3. So 27 can be written as 3 root 3. 5 times 2, we get 10 root 3 plus 6 root 3. And I get an answer of 16 root 3 is my answer. That one's for number 11. So when you're adding and subtracting radicals, this key is getting the same number under a radical so you can simplify. The next one, root 6, I can't do anything with. Root 72 minus 2 root 54. So 72 is 2 and 36, 2 and 18, 2 and 9, 3 and 3. Pair of 3s, pair of 2s. That becomes 6 root 2. So root 6 plus 6 root 2, can't do anything with that. But 54 becomes 2 and 27, 3 and 9, 3 and 3. We have a pair of 3s with a 2 and a 3 left over. So that becomes 3 root 6. Root 6 plus 6 root 2 minus 6 root 6. I can combine the root 6 and the negative 6 root 6. So 6 root 2 minus 5 root 6 is our answer. Okay, so for number 13, we're going to simplify. 3 root 2 plus 5. Root 2 minus 3. We're simply foiling. 3 root 2 times root 2 minus 3 times 3 root 2 plus 5 root 2 minus 15. Root 2 times root 2 is 2. 2 times 3 is 6. Negative 3 times 3, negative 9 root 2 plus 5 root 2 minus 15. 6 minus 15 is negative 9. Negative 9 into positive 5 is a negative 4. So the answer is negative 9 minus 4 root 2. We're simply foiling there. So for number 14, we're doing the same exact thing. 4 root 6 plus 3 root 6 minus 2. 4 root 6 times root 6 minus 2 times 4 root 6 plus 3 root 6 minus 6. Oops. Root 6 times root 6 is 6. 6 times 4 is 24. Two times 4 root 6 is a negative 8 root 6. Plus 3 root 6 minus 6. So 24 minus 6 is 18. And we get negative 5 root 6. Now I don't like how my numbers kind of got scrunched there, so let me redo that down here. 4 root 6 times root 6 minus 2 times 4 root 6 plus 3 root 6 minus 6. That's what the foiling should look like, but that right there is the answer. Okay. And now we go on to solving them. When you solve them, this is 15 here, you've got to get the radical alone. Subtract 5. Now my radical is alone. And we're going to square both sides. When you square a radical, that's what makes it disappear. That equals 100. We add 3 to both sides. And my answer is going to be 103. You can plug that back in to check. Number 16, we're going to skip till the next video because there won't be time to go through it. So I'm going to jump ahead to number 17 here because I will have time to do that one. Put it down here. 17, 6 minus the square root of 3x plus 5 equals 5. Okay, we subtract 6 on both sides. Negative root 3x plus 5 equals a negative 1. And then I'm going to multiply both sides by a negative 1. So now my radical is equal to a positive. We square both sides. 3x plus 5 equals 1. When you subtract 5 on both sides, you get negative 4. And you divide by 3, my x is negative 4/3. And you can plug these numbers in and try them to make sure they work